So we covered methods in Chapter 7. Chapter 8, Advanced Method Concepts. Here's the cool stuff. Using reference parameters, out parameters, and parameter arrays. Also overloading methods. If you've taken Java, you're familiar with the idea of overloading methods. However, reference parameters and out parameters are completely new to you. This is how you can pass in by reference rather than by value, by copy, which is really pretty cool. C# did have that. Excuse me, C++. So, understanding parameter types. A mandatory parameter. An argument for it is required in every method call. There are types of mandatory parameters. You can have reference parameters, which you define with the reference modifier, meaning that the method can actually change, completely change the argument that's passed in. Output parameters. Those are ones that are declared with the out modifier, so they do completely change it, but you're not necessarily passing in a useful value. What you really want to know is what kind of output you're getting from it. And then parameter arrays, declared with the params modifier. So what is an optional parameter? An optional parameter is one that's declared with default values. And then a value parameter. The value parameter receives a copy of the value passed to it. The copy is stored at a memory address, and that's the kind that we've been using all along, rather than the actual parameter. So changes to value parameters never affect the original argument to the calling method, unlike reference parameters. So value parameters of what we've been using. Mandatory value parameters. This is just the same kind of thing we've been talking about all along. Display value parameter. This is our function. It accepts a parameter named x. So when we invoke it, we call it by its name and we pass in an argument. And here we are reassigning x to a different value for whatever purpose. And then we are writing it out. But by the time we get back, x is still unchanged because this x is simply a copy. It's a different memory address than this one. If you reset it, it doesn't have any effect to this one. So that's a value parameter. It's called a mandatory one because there's no default value for x. I want to skip ahead. Optional parameters. An optional parameter is one for which a default value is automatically supplied. You provide a value for it in the method declaration. Only value parameters can be given default values. That kind of makes sense. You'll see why when we start talking about reference. Any optional parameters in a parameter list must follow all the mandatory parameters. So we're just going to create a silly little demonstration of optional parameters versus mandatory ones. I'm going to create my usual console application. Console.read key at the bottom. Alright, so let's see. Here's our class. I'm going to create another static method. It has to be static because we're going to be invoking it from a static method in the same class. So static, I'm just going to call this mandatory, M-A-N-D, int x. Let's do something. Let's print out mandatory x equals, what am I doing? Cout, that's C++. Console.writeLine mandatory x is placeholder 0, comma x. Something to note here. is you could tack on a lot of placeholders, right? X comma Y comma Z, you know, stuff like that. Just think about what's going on there. Or don't think about what's going on there. Question how it could happen. How could you write one method that could accept one argument, or 2, or 3, or 400? All right, so anyways, we have I forgot to declare its type. That's why it keeps yelling at me there. Okay, static void mand. So down here, inside main, if I want to call that function, I can't call it like that. It's going to give me an error because I'm not passing in a value. This is a mandatory value parameter. I need to pass in a value. All right, that'll get it to work. I am now passing in a value. But I'm going to create a different method that takes an optional parameter. So static void opt for optional, int x is equal to -345, whatever, 234. It's going to console out the same thing. Console.writeLine optional x is placeholder 0, end quote, comma x. But we're going to call it twice. Down here, we're going to call optional with a value and then optional without a value, right? Works either way. Works because we have an optional value that'll fill it in if we do not pass in an argument. Okay, so if I run it, it's going to print mandatory 100, optional 100, and then it's going to print optional -234 because that's our default value for that variable. All right, as expected.
Does Java do that?
Java doesn't have that. Okay, let's find out. Let's make absolutely sure. The question was, does Java do that? Java optional parameters. How do I use optional parameters in Java? Var_args could do it. That's when you have a variable a variable list of arguments, which is an array. Other than that, all variables in a declaration must be supplied. So no, it's not nearly that easy to do it in Java. You could only do it by passing in an array of values. And the array could be of length 0. You still have to pass in something. So if you wanted this to happen and you didn't have the ability to provide an optional value, you could simply overload the method with a different version. Static void opt, like that. And inside it would create a variable like that. And then it could write it out. So we've overloaded this method. One version of it takes a parameter, the other one doesn't. Now my question is which version of it did it invoke? Did it invoke this version? Let's find out. This version of opt is going to set it equal to -999, whereas this one sets x equal to 234. So it set it equal to 999. It actually invoked this one. Maybe we'll see why. Anyway, so that's an overload of it. But you don't, that's how you would do it in Java most likely. But you don't have to do it like that in C# when you can provide optional values. So what you cannot do though is something like this. I'm going to write a different one. Static void bad option. You can't say int x is equal to 0, y, int y. The mandatory parameters have to precede the optional ones. So you'd have to take that and put it before that, you know, int y, comma, int x is equal to 0, whatever. I'm going to get back to where I was, but then I'm just going to comment this out, right? Static void bad option, int x is equal to 0, int y, mandatory parameters cannot follow optional parameters. Or to word it vice versa, optional parameters must follow any mandatory parameters. And that makes sense, right? Because if you called this and you had an optional parameter and a mandatory one, how would it know which, just wouldn't make any sense at all. Wouldn't know whether you were passing that one in as the optional or as the mandatory. But if the mandatory one comes first, then you know that that fills in the mandatory and then any other ones are optional. So your method can have as many mandatory methods as you need. There may be a limit, but you can put 10 or 20 mandatory parameters as you need. And then you could also put in as many optional parameters as you need. I don't know if I like saying that. I'm going to rewind that statement and just drop that off for now. Heck, let's test it. Can we do this? Static void test. Can we do int x is equal to 10, y is equal to 20? And the answer is yeah, we can. That was supposed to be int y is equal to 20. Int x is equal to 10, int y is equal to 20. So when you call test, you could fill in both parameters, you could only fill in one, or you could leave them both off. So test here, we're going to fill in both of them. Here we're going to fill in only one of them. Why did I type int? Test 1, now we're only filling in one of them. Or if we call it with none of them provided, then both of the default values for the optional parameters are used.
Okay. Is there any way you could just do the second one?
No, no. The question is, can you make it so that you're filling in the second value but not the first? No. You have to do them in order. Here's our example. Display the size, length, width, and oh, by the way, we have a third parameter called height, but we're going to default it to 1. So when you call it, you could display size with 2 arguments, or you could display the size with 3 arguments. This is a list of optional parameter header definitions, method definitions, and whether they are valid or not. Int A, int B, int C, int D is equal to 10. That's valid because the optional one follows all the mandatories. Int A, int B is equal to 3, int C. That's invalid because we have a optional one tucked in before one of our mandatory parameters. Int A is equal to 3, int B is equal to 4, int C is equal to 5. Totally valid. They're all optional. Int A, int B, int C, totally valid. Int A is equal to 4, int B, int C is equal to 8. Again, we have an optional one tucked in before a mandatory one, so that's invalid. When calling a method with optional parameters, and you're using unnamed arguments, leave out any arguments to the right of the last one you use. So you have this method here, int A, character B, int C is equal to 22, D is equal to 32. You call it with 1A, 3, and 4.4. You fill in all variables. 1, K, and 9. You're filling in 3 of those variables. Calling it with 5 and D. You're filling in 2 of them. Now you're filling it in with 1. Now you're filling it in with 0. And then you try filling it in with 3 and 18.5. That doesn't work because the second one has to be a character according to its definition. Right there. You can't just skip that one and then start filling in the third one. Same problem's wrong here. Named arguments. Named arguments are method arguments that are preceded with the name of the called method's parameter to which it will be assigned. And you may remember these from Python if you've learned Python. You could do this if you're going to print something. This is not good code. Don't bother typing it in. I mean, it's not good for... you could say print, hello, comma, END is equal to that. It was a named parameter right there. You didn't have to type END is equal to that, but if you did, it would use it. And the print statement took more than one optional named parameter. If you wanted to print out something and you wanted to put, instead of a comma between each one, instead of a space in front of each one, you wanted commas between them, you could do that. All right, that's Python. We're getting rid of that. So each unnamed argument is known as a positional argument. Your named argument has to appear after all the other unnamed arguments have been listed. Here we've got static void main. It takes an int, it takes a character, it takes a C, and it takes a D. And this is how you accomplish the thing where you're filling in values kind of out of order. Here's what you're doing. Method 1, comma A, that works because you're filling in both of them. And here we see how the named parameter works. This is saying we want to fill in the C argument with the value 3. And we want to fill in the D value here. We better type this one up. But anyways, you prefix the name of the parameter and then you do a colon followed by its value. So let's do one of our area of cube type assignments or block. So static double area cube, and it's going to take a height with a default value of 1. Why did I make it an int? Probably because it's easier to type int than double. A height with a default value of 1, a width with a default value of 1, and a depth with a default value of 1. And I forgot the data type, so it's double height, comma, double space, width is equal to 1, comma, double depth is equal to 1. Do you need all that spaces and tabbing? No, obviously not. You can put it all on one line. Alright, hope that's clear. Alrighty, and then the area, double area, is equal to the height times the width times the depth. And we're going to return the area. Where are you underlined? Okay, that went away. So we can call it several different ways. Double, whatever, area is equal to the area of a cube, like that. It's just going to be 1 times 1 times 1. You could call it like this. Area is equal to the area of the cube. We're going to just fill in one value, so that's going to be 100 by 1 by 1. Oh, excuse me, you can't read it clear the variable. So area is equal to area of the cube, whatever, and we could do it with 2 variables, we could do 3, but we can also use parameter names. Area of a cube, the height is equal to 10, height colon 10, comma, depth colon 5, like that. So we're filling in the height variable, we're filling in the depth variable, but we're not filling in the width. Do they need to be in order? No. Area is equal to the area cube. Depth is equal to 2.5, not colon, excuse me. I think I said colon and typed equal. Depth colon 2.5 comma, and then the height, colon, 10, right? And then we're not filling in the width, but we could. Area is equal to the area of the cube. Let's do them in opposite order. Depth, colon, 1 or 10, comma, width, colon, 10, comma, height, colon, 10. That's pretty cool. I don't recall Java allowing that in any fashion. Python does. Except Python uses the equal sign rather than the colon to indicate them. Is that not cool? Yeah, that's cool.
That's how I was like, well, because when I asked you earlier if there was a way to like skip a parameter.
Yeah. This allows you to skip the parameter. It's not exactly skipping it, but yeah, same idea. Why you would do that? Flexibility with method calls. Your named arguments can be coded in any order as long as they follow all the unnamed arguments. You can do this to result in fewer overloaded methods. Self-documenting programs. What does that mean? You're looking at it, you see this, say this had a really bad method name. Instead of being called area cube, it was just called, something in, Czechoslovakian, bez pitange, whatever, I'm just typing garbage there. You don't know what nezitange is, but you do know that it's taking a depth and a width and a height. That's really pretty useful information. You're already armed with information before you scroll up or read some documentation about what that function does. And their example is very similar. Display employee data, where you say should hide salary colon true. When you're reading the code, that makes real clear what this second parameter is and how it's going to dictate the behavior of that method that you're invoking, rather than just passing in true with no name there. Now typically what you do in a language that doesn't support named parameters is you would do this. Should hide salary is equal to true, and then you pass that in, right? Like that as a flag. That's better than nothing, but this is better still. I'm going to undo those changes. Okay, so here's a way that they did a method called closing, like the closing of a letter. Sincerely, your best regards, James O'Hara. And they wrote two different versions of it. They overloaded it so that we have one version that accepts a string and another that doesn't accept a name, and it defaults to saying James O'Hara. And then a single implementation of closing with an optional parameter. Right, so you can leave that in or you could take it out. One method replacing two methods. Disadvantage to using named arguments. Implementation hiding is compromised. Changes to the called method could cause problems, requiring changes to the calling method in the program.
Dare they use the out parameter without telling us what it does?
I skipped ahead.
Oh, okay.
All right. They don't give any further explanation on those bullet points. Let's go back and look at the ref parameter. I'm going to have to reread that because I don't recall why you would say that. I don't see why implementation hiding is any more compromised than it would be, you know, just from a list of parameters with names. You could always look up the names of the parameters. But anyways, okay, we're going to go and scroll back and look at reference parameters. So we've talked about mandatory value parameters. Reference parameters. Sorry. So a reference parameter, when you pass a variable in, the reference parameter holds the memory address of the variable that is being passed in, which allows the method to alter the original variable. So a reference parameter needs to contain a value before calling the method. I think this could be better demonstrated just by going in and writing one. You know, in the past we wrote something called change me and it didn't work. We tried to set x to 999 or something and it didn't work. This time it's going to work. So static void change me reference int x. And it sets x equal to 999. So down here when we invoke it, you know, we could say, let's give it a different variable name other than x. You know, int test me is equal to 0. Because it's not the name of the variable that's important, it's the memory address. And then so we're going to call change me and pass the test me variable in as an argument. But that's not good enough. We actually have to say that it is a reference, like that. Now they could have written the compiler in such a way that you did not have to prefix the variable with this keyword, that declaring it here would be enough. But they did that to just hammer in, when you're looking at the code, oh, test me could get changed. So even without having access to this code, when you looked at it, you could see that it's possible that test me might get changed. It's just a big red flag. Test me could be changed. So if we write it out, console.writeLine parentheses quote test me equals placeholder 0 end placeholder end quote comma and then that variable name test me parentheses semicolon. When we print it out, it's not going to print that it's 0. It's going to print that it's 999. Whereas if we took this ref keyword out here and this ref keyword out here, it would print out that it was 0, no matter what happened here, because x would merely be a copy of this variable. Instead, they are the same thing. They are two references to the same memory address. So any change that happens to x in here changes this value as well. Going to run it and prove that it works. Yeah, test me is equal to 999. So that's a reference value.
Would it be the reason that SS can't convert from void to bool? I don't know why it's calling my changing method bool.
Alright, I'm going to have to come back there to look at that. So the question was, why didn't this little bit of code work? I'm going to type it, but it's an error, so we're going to wind up deleting it. Console.writeLine change me of our variable. Right, like that. But why does that work? It gives a pretty cryptic error message. It says it must be a bool or something like that. I'm not quite seeing that, but what's going on? Change me doesn't return anything. It returns a void, so we can't use it as an argument for another function. You just invoke it on its own line. If you want to, you could do this, return x there, and you could change its return type. And that's not necessarily an uncommon way of handling this. I don't know. I would instead make x. Nah. This is the kind of thing where you want to pass back more than one value. You know, you want to return one value, but you also want to affect another value so that you can check it, just like the Tryparse. So I wouldn't both return the same variable that I was influencing there. So I'm going to undo those changes. It's still going to be static void change me, and I'm deleting this line down here or commenting it out. So something to notice here is if I call change me but I use an uninitialized variable, it's going to complain. So int Fred, the uninitialized variable, change me Fred. Okay, it's not going to compile because I didn't put the reference keyword there. Change me reference Fred. And it's underlining it as an error. And they go, well, why is it doing that? All we're going to do is, when we pass it in, we're going to set its value. Ought to work, but C# implements a different keyword for the passing in of unreferenced variables. A reference variable is supposed to be initialized. It has to be initialized before you can call it. So the ref keyword dictates that it is mandatory that the value be initialized. So if we wanted to get rid of that, we could do, set it equal to 0. But what if you have something that you know? Well, the best example is Tryparse. And it gives it away. We're going to parse a string, and we're going to pass in a variable called OK, right? And so we put the word out in front of it. Out means that value is going to get erased. It does not matter what we set it to beforehand. So it doesn't have to be initialized. I'm going to delete that line. Let's write another method that takes an out parameter. Static void change to out int x. And all it needs to do is set x equal to a value, 7654. Now down here, when we invoke it, I'm going to delete it. No, I'm not. But I am going to take out where we initialized Fred. So it says int Fred semicolon. And then change me reference Fred, which is going to be a syntax error. I'm going to have to comment it out. And then change me to, and then add the word out Fred. Excuse me, it was just change to. Looking up at the name of it here. So change to. All right, so it's complaining Fred has not been initialized, and it's true. So the reason why is because if you're passing in something as a ref, it does have to be initialized. And if you're writing something where you don't care about the value being passed in, it's just going to get wiped out. For example, Tryparse, you don't care if you're passing in a true or false. All you care about is what it returns to tell you whether it's successfully parsed or not. So comment that line out, the change me line. I'm going to put a comment here. A ref variable must be initialized. An out variable does not have to be initialized. Declaring something as out implies that the method does not use the Fred, the parameter, for anything except output. Now, conceivably, you could pass in good data, with the out variable. This function up here, change to, could use x for something. But since you could write code that leaves x uninitialized, it would be a terribly bad idea. Let's see if that's true. Could we do x plus plus there, or is it going to say, oh, by the way, we don't even know if x has a value? All right, it's going to complain. use of unassigned out parameter x.
What if you do it after?
Yeah, you could do it afterwards, but that's because it's been assigned. Okay. So something to notice about reference parameters of either kind. Down here we have one called change me, and we're going to pass in 100. And oh, that's not going to compile, so I'm going to put the word ref in front of it. You can't do that. This is a literal. It's a constant. The reference in the message printed out underneath it that you can't read because it's too small, a ref or out argument must be an assignable variable. So it can't be a constant, and it can't be, an unnamed constant, a literal. Because it makes absolutely no sense to be passing in something to 100 and then somehow have that number 100 become 999. What does that even mean? Okay, so I'm going to comment that call out and say in my comments, a ref or an out argument must be an assignable variable, not a const, not a literal. So that's a reference variable. That's an out variable. I love those. Love the ability to do that. So we've talked about reference parameters and output parameters. Then there's parameter arrays. So the first page was using a ref parameter, the next one's using an out parameter. We've demonstrated those. The Tryparse method, as I've mentioned, requires two parameters, the value to be converted, and an out parameter to hold the result.
But returns a boolean. And see, this is the first time I've ever seen that, so it's absolutely like mind-boggling that I've never seen it in another programming language, and then there's this, and it's like, that's amazing.
Yeah. Well, Python lets you return multiple values, so they can get around it that way. You just return x, comma, y, comma, z. But all these other languages that return one value, I like it. I like the ability to do that.
And when you were telling me about a method returning multiple values, I thought you meant that you could do like return x, y, and z, but there's no way for you to do that because you can't store.
Well, you can in Python.
Oh, you can?
Yeah. The question is, returning multiple values. And again, this is Python code, not C#, so we're veering off. But we have the question: can you return multiple values? And the answer is yes. So you have define myfunc, and it's going to return 1, 2, 3, and then when you're ready to call it, you do x, y, z is equal. Well, yeah. X, y, z. Oh, really?
It's gonna do it every time.
A, comma, whatever. My value, comma, your value, comma, their value is equal to my f, like that. And then so when it's done, 1 has gotten copied into my value, 2 has gotten copied into your value, and 3 has gotten copied into their value. That's how you get more data out in a language, in Python, where you don't have reference types. Other things you could do is you could create a class, and you could pass something in as an object, and your method could change the value of that member and pass it back. Or you could create an array, and you could pass values back as an array. But it's really nice not to have to mess with those more complex methods if you have that ability. I would actually like to save talking about parameter arrays for the next lecture. So the homework. I probably need to change the name of the assignment just to programming exercise methods. So write a program that meets the following requirements. Write a method that prompts for a number. between 1 and 3 to represent values. So if you have a rectangle or a block, then they're going to type in a 1. If they're going to want a square, it's a two-dimensional thing, then it's going to be a rectangle. Well, that's silly. But anyways, yeah, 1's a square, 2's a rectangle, 3 is a 3D block. So the function will need to return an int containing the value, or you could pass it back as a reference or an out parameter, your choice. And I'm not telling you the name of it. But anyways, you store that into an integer named sides. If it's got one side, we're assuming it's a square. If it's got two sides, we're assuming it's a rectangle. If it's got three sides, it's a block. So based on that information, you prompt the user for up to three values. If they only want one value, then you only ask them for one. If they want two values, you fill in two. If they want three values, you fill in three. And I give an example here. Void get values, where you pass in the number of sides, and then reference int x, reference int y, and reference int z, where sides is equal to number of the links to fill in. Or you could play with writing three different overloaded get value methods. So then write an overloaded method called Calc Area. If it's only got one side, it's a square, you know how to calculate the area of a square. X times x. Two sides, area is equal to x times y. Three sides, it's a block, so it's 2 times, x times y plus x times z plus y times z. Then display the result of that. So extra credit, turn in a version that replaces the 3 Calc Area methods, or 1 if that's all you did, with a params keyword that accepts 1, 2, or 3 int. Now this we did not lecture over yet. You can hit the book, you could wait for the next lecture. Below is this sample output. Alright, so this obviously could be implemented more simply than the way that this is asking you to do it, right? If you didn't use methods at all, you could just write, procedural code. You ask for something, you get some values, and you print it out. But I do want you to write it as methods. Specifically, we need at least one method that prompts a user and passes back the number of sides that they want, and then another one called get values, and then a third one called Calc Area. Alright, I hope that makes sense. Along with that, another assignment's coming up. Oh, I see why I call it 6. However, this chapter has changed its name, has it not? This is for 7 and 8. I will modify that. I did call it Chapter 7 here. There's also another one called CS Fighter. And this has got a longer description. Got a 6-page description. Is it that complex? No. But I documented it very carefully so that the combat system, CS Fighter stands for C# Fighter, is very, very clear. And so I'm going to just scroll through this really quickly. The idea is that you create 2 fighters. They both have names. They both have a certain number of hit points. They both have a certain armor. I don't know why I called it armors. And a certain number of attack dice. The attack dice are rolled in order to generate random numbers. The hit points is how many hits they can absorb, and there's also a bonus that gets added to their attack dice based on their hit points. So whoever wins that roll, the loser is going to take damage, but that damage is affected by the armor. So here we have somebody named Conan. He's got 10 hit points. His armor can absorb up to 2 hits per round, and he rolls 5 6-sided dice to generate his attack. Alright. Here's our example. Again, Conan, who's got 10 hit points, he's got an armor of 2, and he's got attack dice of 5. His opponent's got 6 attack dice, but the other stats are the same. You determine the attacks. Conan has 5 dice, so he rolls some 5 dice. They add up to 22. That's his base attack roll. His bonus is 1/2 his hit points. He had 10 hit points, so his bonus is 5. So his total roll is a 22 plus the 5 for a total of 27. Now his opponent rolled. His opponent's rolled a 5 plus 4, whatever, for a total of 32. So you compare the attacks. The attacks are not equal. Conan rolled less than his opponent. So Conan loses this round. His opponent rolled 32, he rolled 27, so he took 5 points of damage. That's the raw damage, but the real damage is the raw damage minus the armor. So the damage was 5, but his armor was 2, so he takes 3 hits of damage. His hit points are lowered by 3. He now would have a hit point of 7. You keep repeating those steps. Alright, I meant to delete this because this is an optional suggestion. After a battle, after you declare the winner, you could show a history of the hit points for each fighter. This battle took 4 rounds. You know, in the first one, Conan dropped a little bit. In the second round, Conan dropped a lot further. On the third round, Conan, okay, these are not actually a valid one, but it's the idea. And then on the fourth round, Conan is defeated. Poor guy. On this one, you know, his opponent, I should have put an opponent name there. I will tidy that up. I will indicate that this is optional. And yeah, see, there it is on the second page, mentioning that it's optional. And so on the next page there is, so I can just delete that section right now. I gave the same assignment to my scripting students, and in Python they had already covered lists, so it made that feature, the hit points history, really easy to do. We haven't talked about lists as far as I recall. We've talked about arrays. Is that true?
Yeah.
Yeah, okay. So then sample output, the game runs, it's all done. Last thing I want you to consider is how to prevent endless battles. If their armor is too tough, they won't ever take any damage. They'll just sit there and wail at each other, and it doesn't matter who, you know, wins each round. The armor absorbs it all. And so you can prove that to yourself by giving your characters a really high armor. The program will loop round after round. It might loop thousands of times. You know, maybe if one of them rolled all 1s and the other rolled all 6s, they might take damage. But if you make your armor so good that no possible damage can be generated, it's an infinite loop. So how can it be solved? I give some ideas. The easiest one is if you just limit the number of rounds. You know, after 10 rounds, the combat's over. If there's no winner, you call it a tie. That's a boring one, so don't do that one. Maybe you could make the minimum damage 1, no matter what. So no matter how good their armor is, they're going to take at least 1 damage. That way, you know, the hit points go down every time and the battle will be resolved. Then there's some other ideas. Maybe the number of attack dice gets increased as the combat goes on. The fighters get angrier. Whatever. Okay, so I hope the instructions are clear. The combat system is a lot simpler than it really would take 6 pages to talk about, but I hope that that makes it more clear rather than less. So our due dates for these, let me save this and save it as a PDF as well. We will make the first one, the square rectangle block one, due in about a week, and the CS fighter one due in about 2 weeks. Where did the C# fighter get saved? Anyways, I'll fix that later. So this one we will make due, it says October 30. That doesn't sound right at all. It's really going to be due a week from today, about so. And although it looks like you have a lot of time for that one, assuming you watch the lecture quickly, it really is a pretty easy assignment, so immediately start working on the other one. So apparently the last time I taught the class we got to that one more quickly. And then the next one, CS Fighter, will be due, okay. I just edited the wrong thing and I don't know what I edited. Anyways, Chapter 9, going to be due, Homework 9 going to be due about a week. CS Fighter is going to be due in about 2 weeks. Alrighty, stay tuned for the next part of the lecture where we finish up Chapter 8.